Mulberry cultivation for engaged silkworms. Dear students, in today's lecture, let's make an attempt to know about mulberry cultivation for engaged silkworms. Introduction. Rearing of engaged silkworms up to second moult is called as chalky rearing, which usually lasts up to 10 days and is a vital aspect of sericulture industry. Ultimately, robust and healthy worms only can produce quality cocoons. The quality of mulberry used in the rearing of engaged silkworm is a major factor controlling the silkworm crop. In order to obtain good quality of mulberry for rearing engaged silkworms, it is very much essential to establish the mulberry garden, exclusively for the rearing of chalky silkworms. Therefore, chalky rearing is a vital part of silkworm rearing for development of healthy worms, which ultimately determines the success of a cocoon crop. Characteristics of chalky worms. Chalky worms consume only 6% of total feed but show 400 times increase in body weight, 300 times in body size and 500 times in silk gland weight under ideal conditions. Their body temperature is higher than the atmospheric temperature by about 1 degree centigrade. They grow extremely fast under high temperature up to 30 degrees centigrade and high humidity up to 90%. Chalky worms require a high temperature of 27 to 28 degrees centigrade and a humidity of 85 to 90%. They prefer dim light of 20 to 30 lux. The dim light during daytime 16 hours a day and darkness 8 hours a day during night is more congenial for their healthy growth. Other important factors determining the success of cocoon crop are the health care and hygiene during the chalky rearing. Need of chalky mulberry garden. One of the most vital factors contributing to successful engaged silkworm rearing is the supply of highly nutritious mulberry leaves. Moreover, the qualitative and quantitative requirements of the leaf fed to silkworm are totally different from that of late age silkworms. The engaged silkworms require mulberry leaves that are soft, succulent with high moisture content, that is 80%, and rich in both protein 25% and sugar carbohydrates 14%, whereas the late age silkworms on the other hand feed on coarser leaves with high protein but less moisture and carbohydrate content. Such specific quality leaves are not produced from a general garden where the leaves contain less moisture, that is 70%, leaf protein 21% and leaf sugar 11%. Hence, mulberry garden exclusively for chalky rearing is essential. Though the importance of chalky rearing centers has been established to serve the needs of the farmers, the production of quality leaf in adequate quantity has not been fully met. Hence, keeping in view the needs of the sericulture industry, suitable package of practices has been developed to raise an exclusive garden for chalky rearing. Mulberry varieties such as S36, V1, G2 etc. have been evolved for raising chalky garden which produce quality leaves and meet the standards required for the chalky worms. Besides, harvesting sufficient quantity of mulberry of good quality for chalky rearing, the establishment of mulberry garden exclusively for chalky rearing is also beneficial in maintaining a better physiological functioning in the mulberry plants as well as to increase the efficiency of the mulberry. Also, it is essential to rear healthy silkworms during young stage by supplying mulberry of good quality, that too exclusively grown for feeding young silkworms, and carefully managing the special mulberry garden with all necessary precautions. Because the quality of mulberry leaves supplied to chalky worms is also closely related to the occurrence of disease of silkworms like flatchery. As far as area of the mulberry garden to be enmarked to chalky rearing is concerned, it can be roughly decided that 10% of the total area of the mulberry garden is to be kept for the purpose. But now, under the Cluster Promotion Program, that is CPP of Central Silk Board, Chaki Centers concept has been given greater importance and it has been taken up by many progressive farmers as an entrepreneurship in a big way in the traditional sericulture belt of the country. Advantages of Chaki rearing centers: stabilization of cocoon crop and increase in yield, improvement in quality of cocoons, control over spread of diseases, reduction in rearing expenditure, distribution of labor for other works. The concept of Chaki rearing is not new. In developed countries like Japan, China and Korea, Chaki worms are supplied to the farmers in majority. For example, in Japan about 95% of the worms are distributed only after Chaki rearing. On the contrary, in India, only about 10 to 15% of the rearers received Chaki reared worms. However, the farmers are being advised to get only Chaki worms from CRCs for rearing programs, instead of procuring silkworm laying directly from the grainages. In this direction, several types of garden schedules have been formulated for establishing exclusive Chaki garden. Unlike China and Japan, in our country, the situation is more heterogeneous with regard to rearing facilities, environmental conditions and cultivation practices. Chaki rearing is a must to reduce the crop loss and to increase the cocoon yield. The basic requirements for Chaki rearing are a well-maintained irrigated mulberry garden, a suitable rearing house with required appliances and well-trained manpower. The Central Sericulture Research and Training Institute, Mysore, has developed a specific package of practices covering all aspects of Chaki rearing to make it economically viable and easily adaptable. Technology for raising Chaki garden. Number 1. Selection of site and land preparation. The Chaki mulberry garden must be established in flat lands with porous fertile soil having good drainage. The soil should be sandy loam or clay loam having a pH range from 6.5 to 7.5 and organic carbon above 0.65% is preferred. The site should be free of nematodes and termites infestations and should have a sure source of irrigation. Area: 2 acres in 4 blocks of half acre each with 32 crops per year, that is 8 crops per plot. Varieties suitable for Chaki rearing: S36, V1 or G2 newly evolved. S36. Variety S36 was evolved from self seeds of Berhampur local variety by chemical mutagenesis. It is characterized by short internodes, semi-erect and medium branching with greyish pink stem color. Leaves are unlobed, cordate, glossy, pale green with smooth surface. It is recommended for irrigated conditions, especially for rearing Chaki silkworms with recommended packages of practice. It yields about 28 metric tons of Chaki leaf per hectare per year because of high succulence and nutritive quality. It is found more suitable for engaged silkworm rearing. As the variety has moderate rooting ability, it is suggested to use only saplings for establishment of the garden. V1. V1 is the popularly known as Victory 1. It is a selection from cross-pollinated hybrids of S30 and Berhampur C 776. The variety is characterized by high erect branches with greyish stem color. Leaves are thick, succulent, large, entire and ovate with truncate base. Leaves are smooth and glossy, fast growth and high leaf yield. Under irrigated conditions, with recommended package of practices, it yields about 32 metric tons of chalky leaf per hectare per year with excellent leaf quality. G2. Variety G2 is a high yielding mulberry variety recommended for raising mulberry garden exclusively for engaged silkworm. With succulent foliage, G2 is most suitable for chalky rearing with assured irrigation and recommended package of practices. It has a yield potential of yielding about 38 metric tons chalky leaves per hectare per year with 8 crop schedules of alternate leaf picking and should harvest. The variety is a hybrid of Morus multicalis and S36 and is characterized by erect branches, thick dark green cordate leaves, high moisture content, that is 80.30%, high moisture retention 83.40%, high sprouting 96% and rooting ability 94%. G2 variety yields 33% more chalky leaves than S36 and 20% more than V1. It can be easily propagated through cuttings. It has got a quick regeneration capacity and is moderately resistant to leaf spot and leaf rust. Few agronomic parameters of variety of S36, V1 and G2 are as follows. Sprouting on 30th day is observed to be 70%, 90% and 96% respectively. 100 leaf weight is found to be 465 grams, 560 grams and 460 grams. Rooting ability on 90th day is 48%, 94% and 94%. Spacing. Indo-Japanese system of plantation, that is paired row with 5 feet plus 5 feet into 2 feet or 4 feet plus 3 feet into 2 feet suitable for mechanized cultivation is recommended. Since the plants are not allowed to grow beyond 45 days, this system with 4 feet plus 3 feet into 2 feet spacing, that is 6,300 plants per acre, is also preferred. Further, any existing mulberry garden with a spacing of 60 cm into 60 cm can also be converted into a chalky plot. A spacing of 90 into 90 cm can also be followed, which can accommodate about 4,840 saplings per acre of land. However, wider spacing of paired row method is more advantageous. Planting material. Healthy 100 to 120 days old saplings of 100 to 120 cm height can be used for planting. Because of already developed root system in saplings, plants gets established quickly and grow vigorously. Planting. Planting work can be taken up soon after the onset of regular southwest monsoon. One sapling per pit is placed deep and straight. After this, the soil around the saplings must be pressed firmly. When planting work is over, adequate irrigation has to be provided immediately. Pruning and training. After the establishment period of 8 to 10 months, the plant should be pruned at a crown height of 20 cm above the ground level, preferably during the onset of monsoon season. After 35 days of bottom pruning, harvesting of leaf commences and continues for 7 days, that is feeding the larvae up to second molt. At the end of 10th days, the top terminal buds is to be clipped off. 25 to 30 days after top clipping, second leaf harvesting as shootlet is to be done for rearing of silkworms. Up to second molt, thereafter the plants are again pruned at crown height as earlier, that is 80 to 90 days after the first pruning, depending upon the season and growth. The above cycle of events to be repeated for 4 times to get 8 crops in a year. Thus, the plants are to be pruned at the crown 4 times in a year after second, fourth, sixth and eighth crop. matching the training schedule. However, pruning may be delayed during winter season, November to January. Intercultivation and maintenance during establishment. About 1.5 months after plantation, a light weeding or wooing must be done. Second weeding must be done after 3 months of planting. Weeding operations must be through and should be regularly carried out. After first weeding, gap must be filled by healthy saplings followed by watering. The plantation taken up during the monsoon will have the advantage of receiving fairly distributed rain from June to October. If there is inadequate rain for a period of over 10 days. Irrigation has to be given after the cessation of the monsoon. Irrigation has to be given regularly at an interval of 6 to 7 days, but this frequency varies depending on types of soil. Ultimately, 1.5 to 2 acre inches, that is 34,000 to 45,000 gallons of water is required per irrigation, which can be given by furrow system and whenever possible. Drip or sprinkler irrigation system can be adopted. Manures and fertilizers. Organic input requirement for chalky garden is more than that of the general mulberry garden. Farmyard manures to be applied at the rate of 50 metric tons per hectare per year and preferably in 2 split doses. Accordingly, 40 metric tons of farmyard manure is required for 2 acre chalky rearing at the rate of 10 metric for each block of half acre, 5 metric tons each in May, June and October, November. It is also suggested to apply other organic inputs like VAM, biofertilizer, vermicompost, etc. in desirable quantities to sustain soil health for production of quality mulberry chalky leaf. Chemical fertilizer. The recommended dose of chemical fertilizers NPK is 260:140:140 kg per hectare per year. It is to be applied in 8 equal split doses, that is at the rate of 32.5:17.5:17.5 kg per hectare per crop after each harvest. Chemical fertilizers should be favorably applied in the form of ammonium sulphate, single superphosphate and muriate of potash at the rate of 32 kg, 22 kg, 6 kg respectively for each half acre block per crop. This should be followed by irrigation with an interval of 4 to 5 days. Irrigation. Of all the factors, irrigation is known to bear the highest correlation with respect to yield and quality of mulberry. It requires 1.5 acres inch, that is 3.75 centimeter irrigation water 85,000 gallons per hectare once in 4 to 5 days by ridges and furrows. Accordingly, 68,000 gallons of water, that is 17,000 gallons for each half acre plot is to be given per irrigation. Though the requirement of the water per irrigation in chalky garden do not differ with that of the general mulberry garden. The frequency per crop varies. Leaf harvest. Individual leaf plucking is recommended for first, third, fifth and seventh crops, while the shootlets are to be harvested in second, fourth, sixth and eighth crops for chalky rearing. The plants are to be pruned 4 times a year after taking second, fourth, sixth and eighth crops at 15 to 20 centimeter level. Pest and disease control. Pest and disease control measures are to be taken up regularly. It is advisable to go for mechanical and biological control methods, as the use of chemicals may have an adverse effect on chalky rearing due to early harvest in 8 crop schedules. Advantages of chalky garden technology. Number 1, leaf yield. The chalky garden technology ensures a yield of 32 to 36 tons of chalky leaves per hectare per year. as against 8 to 10 metric tons per hectare per year of chalky leaves obtained from general garden through selected harvesting. In this method, almost 100% of the leaves produced are suitable and used for chalky garden and used for chalky rearing. Number 2, leaf quality. Qualitative leaves produced by the above technology are superior, that is 80% leaf moisture, 25% leaf protein and 13% leaf sugar compared to the leaf obtained from the general garden, that is 70% leaf moisture, 21% leaf protein and 11% leaf sugar. The superior leaf quality has also been proved in feeding trials of chalky rearing. Number 3, rearing capacity. Annually, approximately 1,80,000 to 2 lakhs DFLs per hectare can be reared up to second stage by adopting the above package of practices in 32 to 36 crop schedules at the rate of 20 kg chalky leaves per 100 DFLs. Rearing of engaged silkworms up to second molt is called chalky rearing, which lasts for 10 days. Chalky rearing under ideal environmental conditions, feeding succulent, nutritious, tender leaves with high moisture, that is 80%, protein 25% and sugar or carbohydrates 18% make them grow robust and more tolerant to stress during late age silkworm rearing. Hence, in success of chalky rearing, quality of leaves and maintenance of ideal temperature and humidity condition plays a very significant role. In general, mulberry garden, the leaves contain less moisture, that is 70%, leaf protein 21% and leaf sugar carbohydrate 11%. Hence, mulberry garden exclusively for chalky rearing is essential to meet the requirement of engaged silkworms. Thank you.